بعت لكم by email the PowerPoints we are working on. Okay. Yes. Last time we have done this problem. We finished this problem last time, yes? Guys, do you hear me?
ايه هيدا عامل لي بس
Okay.
بعتقد السيم عملنا.
Yes. بل عملنا كل البروبلم هذا. Yeah, let us start another problem. In the following figure shows a rear view of a spaceship that is rotating about its longitudinal axis at 6 revolutions per minute. The occupants wish to stop this rotation. They have small jets mounted tangentially at a distance of r equal to 3 meters from the axis, as indicated in the figure, and can eject 10 grams per second of gas from each jet with a nozzle of velocity 800 meters per second. For how long must they turn on these jets to stop the rotation? The rotational inertia of the ship around its axis is assumed to be constant. Okay. So let us see what we have here. First, we have this ship is in rotation about its axis, okay? And we know that the omega of rotation is equal to 3 revolutions per minute, okay? And we know that the inertia of this body about its axis is I equal to 4,000. Okay. Now, what we have is that the occupants wish to stop this rotation. So we want to try to stop the rotation. This is why what we will do, okay, they will eject small jets mounted tangentially at a distance of 3 meters from the axis. So here you have jets, okay, and what you want to do is you will eject the jets in a way to stop the rotation. Why this will stop the rotation? Because look, when you eject the jets, you will put on the jets a force, a certain impulse, okay?
بتكون عكس الروتيشن هي ما هيك؟
لا
force
ما
تبع
انت بس كبها in this direction هي حتعمل عليك action in the opposite direction، صح؟ يعني this is the action
انه الجيت بيعملوا رياكشن عكس الروتيشن.
نعم.
يعني هن اذا بس مشي الجيت هن حيكونوا عم يمشوا عكس الروتيشن، مش الجاز طبعا، الجاز بحد ذاته.
مظبوط، هن الجاز حيمشوا مع الروتيشن والاكشن طبعا على الجيت حتكون بعكس الروتيشن، اوكي؟ لانه نحن the action of the on the gas will be يعني هون مثلا هيدي الاكشن of the ship on the gas. So this is the force of ship on gas. So by action reaction, okay, the gas will do an opposite force on the ship, okay, which will tend to decelerate its rotation. لأنه هو حيشد فيه لهالميل، okay, like this. يعني عندنا هون this is the force of gas on ship, F of gas on ship, okay, and also from the other side it is the same. So here also we have F of gas on ship. So this couple اللي عم يعملوا الجاز on the ship will tend to rotate in which direction? It will tend to rotate counterclockwise بعكس الروتيشن of الشيب، يعني حيجرب يبطئوا للشيب، okay? And the question is how much time we should operate the jets in order to stop our system. Okay, this is the question.
مس
نعم.
فينا نجيب المومنت مثلا ناخذ اكس اكسس وواي اكسس يعني ار اي والاف جي
لحظة.
مثل ما عملنا
أول
هذيك
شيء
النهار.
هون يا إلي rotation is about one axis. شو هو الأكسس of rotation هون؟
الميري بالنص.
مظبوط. هذا الأكسس of rotation. أوكي. طيب. أنا the angular momentum that I am applying on my system is equal to what؟ يعني أنا when I am putting initially like أنتوا بتعرفوا initial state صح؟ بتعرفوا إنه omega 0 is equal to 6 revolution per minute. مظبوط؟ This is the first information you know. تاني شغلة بتعرفوا omega final قد إيه لازم تكون omega final؟ What is our purpose at the end؟
زيرو، لازم تكون زيرو.
مظبوط. Omega final is 0. So I know omega initial. I know omega final. I need to find a time delta t. So I should think about what?
Principle of angular momentum.
Very good. Very good. Okay. So here I will apply the principle of angular impulse and momentum. خلينا نعمل فيجر صغيرة. نحن عندنا الشيب. The ship is subjected to a moment. مظبوط. هو كان عم يبرم بالclockwise and it is subjected to a couple of forces حيعملوا عليه moment in the counterclockwise direction. صح؟ The principle of angular and momentum شو بيقول؟ بيقول إنه initial angular momentum plus angular impulse هون لأنه نحن حناخد positive direction clockwise angular impulse حيكون negative صح؟ لأنه حيكون بعكس rotation. So it's minus the moment applied times delta t. نحن هدفنا نجيب what is the time delta t needed to stop the ship and equal to the final angular momentum. بما انه اوميجا انتم بتعرفوا الانجلر momentum of rotation كيف بنجيبه؟ اذا عندي body in rotation الانجلر momentum هو I omega. مظبوط؟ At the final state omega is 0. This is why angular momentum at state 2 is 0. والangular momentum at state 1 is equal to what? Is equal to inertia times omega 1. Okay? بيبقى علينا نجيب the value of delta t is equal to the angular momentum at state 1 over the moment. هلا كيف بدنا نجيب ال value of the moment؟ هيدا اللي ناقصنا بعد. How to get the value of the moment applied here يا شباب. First, this moment is created by two opposite forces. مظبوط؟ هول ال forces are acting at a distance بيناتهم is equal to the diameter of the ship. So the distance between
6
them
متر.
equal to 2r.
السؤال
نعم.
ام دي تي قصدي يعني دلتا تي صح؟
dt is delta t, yes. Okay. يعني هيدي it means the moment times delta t. هكتب لكم اياها. هيدي dt is delta t. Okay. So this is delta t. And we have that this force, how to calculate the force. يعني نحن بنعرف انه المومنت هو F times distance. We still need to determine what is this force. نحن بنعرف انه الفورce in general is calculated by mass times acceleration. صح؟ And we have that يعني we can write it also as d of derivative of mv over dt. مظبوط? So this is a second way to write the force applied. هلا here in this problem, okay, if I go back to the given, what they told me that I am ejecting a mass of, the mass flow rate is 10 grams per second at a velocity of 800 meter per second. يعني انتو بالنيوتن لو يا شباب نحن عادة معودين نكتب MA. بس هي الفورمولا المضبوطة هي sum of forces okay equals to derivative of linear momentum. linear momentum هو mv هلا in general نحن بنشتغل with constant mass فبتطلع الماس لبرا اوكي لبرا الانتجريشن وبيبقى m dv by dt و dv by dt is acceleration. Okay, now in this problem the velocity is known v هي 800 meter per second وعند ال m dot what is m dot هيدي الجرام per second هي dm by dt. Okay, so here in this problem عند ال v constant بتطلع لبرا وبيبقى الماس جوا ففيني اكتب انه sum of forces is v times dm by dt. Okay, v times dm by dt. Since the mass flow rate is given, I can replace dm by dt by 10 gram per second وفينا حولها لل SI units لكيلوغرام per second. I multiply by 10 minus 3 and then I multiply by 800. اوكي يعني هون اذا بدكم هون ظبطوها هيدي لازم نحطها
بس فينا نكتبهم بار ايتاب كمان معروف بس
ايه رح
نفهمها.
عيدهم فرق طاف رح ارجع اكتبه. اوكي هون خليني نظبط لكم اياها. نحن عادة الفورس كيف بنكتبها؟ الفورس هي derivative of mv with respect to time. اوكي هلا نحن عادة باغلب الابلكيشنز اللي بنعملهم بتكون الماس كونستنت صح؟ فبنطلع الماس لبرا وبنعمل ام دي في باي دي تي اللي هي acceleration. اوكي بينما هون in this case in this problem it is different. عندنا الvelocity هي الكونستنت والماس variable لانه you are ejecting a certain jet outside of your system. اتفقنا؟ يعني هون لانه v given constant طلعها لبرا الانتجريشن بيصير الريزولت v times dm over dt times 2r. Okay, now if I continue I have velocity given. Okay, the value of velocity is 800. I will replace by 800 and the value of dm by dt هي the mass flow rate هي 10 gram per second. يعني عندي 800 times 10 times 10 times 10 to the power minus 3 okay times 2r. يعني in total عندي 8 times 2r يعني 16r. okay so this is the value of the moment and now once I find my moment I can replace back into the equation here.
معنى الار مش 3 متر؟
نعم
الار 3 متر.
بلا معنى كل شيء. هون رح يفرجوكم هون عندكم الجواب اخر شيء. يعني الاف مثل ما جبناها انا وياكم هي 8 نيوتن والvalue of r you know it then you just replace in the formula to get the time needed to stop motion. حيطلع 52.4 seconds. الار هي 3 meters يعني الدايمتر هو 6 meters. اوكي
مس
نعم
فيكي بليز من third bullet point ترجعي تقولي لنا شو عملنا؟
yeah okay
ال third bullet point.
this one
ايه هون
okay نحن محمد we are applying the principle of angular impulse and moment. okay
اوكي
هيدا الترم represent what يعني حكتب لكم اياهم هون. عندنا HO1 هو الانيشال angular moment. okay and it is equal to what هو الانيرشيا. مظبوط الانيرشيا times omega at state 1. The inertia is given وomega 1 is given. اوكي.
اوكي
ال HO2 هو ال angular momentum at final state. رح ارجع اكتبها هون. HO2 هو ال final angular momentum. بما انه الاوميجا final يا محمد is 0 يعني شو حيكون ال final angular momentum؟
0
0. فاذا equal to I omega 2 equals to 0. طيب.
اوكي
Now if you replace in the principle of angular impulse and momentum شو بيصير عندك؟ عندك ال HO1 هي inertia times omega 1 اوكي minus moment times delta t اوكي equals to 0. يعني what is delta t؟ انت you want to find delta t صح؟ So
Yeah.
delta t
Equal.
delta t equals to I
Inertia
omega
times
1 inertia times
over
omega 1 over
momentum.
m. طيب بعد بدنا نجيب المومنت بس يعني جبنا الانيرشيا جبنا اوميجا 1 we still need to find the value of
الانرشيا هن عطونا اياها ما هيك؟
yes هن عطونا
اوكي
كله given اوكي هلا تنجيب المومنت عرفت كيف جبنا المومنت؟
فين can we go over it please؟
Yes. So for the moment نحن عنا we have here this ship is subjected to under the action of ejection of gases it's subjected to a couple of force by action reaction in this direction. Okay? How to determine the force here? نحن بنعرف انه in general a force is determined by derivative of linear momentum with respect to time يعني derivative of mv with respect to time. اتفقنا؟ هلا نحن we are used to cases of constant mass فبتطلع m لبرا وبيطلع لنا f equal ma. هون it's different. هون we have a variable mass لأنه you are losing mass from your system. عم يطلع mass لبرا. اوكي؟ بس هن قالوا لي إنه ال velocity of ejection is constant. يعني you have a mass flow rate that is exiting at 10 gram per second. And the corresponding velocity is 800 meters per second. So here, to find the force of the gases on your system, this force can be calculated by V times dm by dt. Okay? V هي the velocity of ejection of the gases اللي هي 800. وال dm by dt هي the flow rate of ejection. Okay? So dm by dt is the flow rate mass flow rate of ejection. Okay?
لأنه V velocity is constant.
Yes, exactly.
وطلع اوكي.
Okay? So mass flow rate of ejection. So just you have now to replace, okay? صار عندك 800 times 10 وتتحولها لكيلوغرام per second تعمل over 1000 فبتطلع equal to 8. Okay? It is 8 Newton. Once you got the force and you know the radius, you can find the couple. The couple who is 2 times radius times f. Okay? And then you replace